So this is a former IB question where we have a cart sitting up on the top of a table over a wheel and axle, and then we have a weight that is hanging down, and it's asking for the equation for the acceleration of the cart. And so it's important to go back and make sure we're all set with that. So let's go ahead and draw a mass on the table, and then we have the mass hanging down. And let's review what we do with these, where we take a look at the motion of the system. So if you remember, right, these two are connected, and so what we do is we say, okay, well, we're going to use the coordinate axis like this. As mass 2 goes down, mass 1 is going to go over, and so this is going to be our x-axis. Let's call this the positive x. We'll call this the negative x this way. And yeah, let's go ahead and figure out the acceleration of the system. So remember, we draw a separate free body diagram for each. Here's mass 1, force of tension going this way, normal force going up, force of gravity going down, and mass 2 over here, force of gravity down, force of tension up. And yeah, we can get the acceleration equations or the sum of forces for each. So for mass 1, all we really care about here for this one is, along the x-axis here. So we have the positive force of tension is equal to, well, really sum of the forces equals m1a. So positive force of tension equals m1a, and that's the acceleration for this. Here, normal force, force of gravity are balanced out. For where this one, force of gravity is pointed downwards, so it's positive. So we have the positive force of gravity plus force of tension's upward here, and so negative force of tension equals m2a. And again, I should write out the sum of the forces equals m2a. Okay. Now we know that the tension force between these is the same. We also know the acceleration is the same between them. So two equations, two unknowns. We can substitute in for force of tension. We could substitute m1a in here, and then solve for the equation for acceleration. So go ahead and finish this one. Go ahead and get the equation for acceleration. And then we have the masses up here. Once you have the acceleration equation, we have the masses up here. Go ahead and find the acceleration and the tension. And it's interesting, if you notice in that last question, they didn't even give any numbers. They just said, okay, here's the system. What's the acceleration equation for the system? So you may or may not need mass. You may just want to find out the acceleration equation for the system. So yeah, go ahead and pause the clip and finish this. And when you're ready to check, you can hit play to continue. All right, so we should get, as we substitute our acceleration equation, acceleration equals m2g over m1 plus m2. And we should get for our acceleration 3.267, and our acceleration is 32.67 newtons. All right, so now for this one, what we're going to take a look at is with friction. So if you remember with friction, let's say this is the coefficient of friction here. If we just want to say, okay, that's, there is friction here, will the system even move? All we got to do is we got to say, okay, is the force of gravity here greater than the force of friction here? If it is, then it will move. So the force of gravity down here is mg, which is the mass 2 is 5, so 5 times 9.8. I believe that's 49 newtons. And then for friction, we've got the normal force here, we got force of gravity. We calculate force of friction is less than or equal to the coefficient of static friction times the normal force, less than or equal to. So the normal force is equal to force of gravity, which is mg, which is 10 times 9.8, which is 98 newtons. So here we have the coefficient, which is 0.3 times 98 newtons, and that comes out to be times 98 comes out to be 29.4 So what that means is the force of gravity here is greater, therefore it will start to accelerate. This will come down, this will go. Now once it's moving, then we need to set it up just like we did in the last one. We set up two separate free body diagrams. Here's mass 1, here's mass 2, two separate sum of the forces. Sum of the forces equals m1a, sum of the forces over here equals m2a. And the only addition now is friction. And then we'll need to substitute in and then get the acceleration equation. So yeah, go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. All right, so for over here, we've got the force of friction going back. We have the positive force of tension to the right. And then we're going to substitute in for force of tension. We can place it in for force of tension. And then when we do that, we'll substitute in. We have to distribute the negative. So we'll do that. This is the acceleration equation, and then we can place our numbers in. We should get an acceleration of 1.96 meters per second squared and a force of 39.2 newtons for tension. All right, so how about for an Atwood machine? If you remember, for an Atwood machine, we take the coordinate axis, goes all the way around. This is the positive x, this is the negative x. And we want to get the acceleration of the system, so two separate free body diagrams, m2 over here and then m1 over here. And for mass 2 we got the force of gravity going down, force of tension going up. For mass 1, force of tension going up, force of gravity going down. We set up our sum of the forces, right, equals m1a, sum of the forces equals m2a. So yeah, see if you can go ahead and finish this one. Make sure you get the signs right based on our coordinate axis. And then once you get the acceleration equation, I'll give you some values to get the actual acceleration. All right, so the acceleration equation we should get is this. And then we can place our values in there. We know that again, here, what's the signs? We'll just look at this real quick. So mass 1, right, the force of tension is pointing upwards towards the positive, so that's positive Ft plus negative force of gravity negative here, right, towards the negative. And then for the other mass, for mass 2, force of tension on this one is negative rather, going this way, right, towards the negative. And then force of gravity is positive going down here. And and then we substitute for force of tension here. We can place that in. Just got to make sure to distribute the negative, and that's a common mistake to forget to do that. And then we get the acceleration of the system. And let's say that the mass is 5.4, and for the mass 1 and mass 2 is 22. Go ahead and pause the clip and calculate the acceleration as well as the force of tension. All right, so for the acceleration, we should get 5.937. And for the force of tension, forgot to prepare that. Let's see that real quick. Mass 5.4 times 5.937. We add that to 5.4 times 9.8. And we should get a total of 84.97 newtons of force. All right, so for this last one, we have a mass on an incline that's connected to the mass that's hanging, so you can go ahead and draw that. We're not going to worry about the angle yet. This is angle theta. And we want to get the acceleration of the system. So, we've got mass 1 on an incline here, so let's get our incline. And we'll need to draw our forces. So we have the force of gravity straight down, our normal force up, and then our force of tension over. And so we'll have the sum of the forces equals m1a. Over here we'll get mass 2, force of gravity straight down, and then force of tension straight up. And we'll set up sum of the forces equals m2a. And we'll call this the positive x down here, and then down back this way the negative x. All right, so with the incline, we're going to need to break this up into the x and y components. This is going to be FGX there, and this is FGY. And yeah, as we place this in here for the sum of the forces, force of tension is positive, pointing out this way. So positive force of tension plus. Now, the FGX is pointing in the negative, so plus negative FGX equals M1A, and then over here, negative force of tension plus positive force of gravity equals M2A. And yeah, so the trick is going to be able to get this in terms of trig. We know that force of gravity is mg. So getting this, what side of the triangle is this? This angle is the same as this angle, So getting this in terms of, this is the opposite side. And then, yeah, setting up and then substituting in. So yeah, go ahead and pause the clip and see if you can get the acceleration equation for this system. And then when you're ready to check, you can hit play to continue. All right, so we should get for our acceleration equation m2g minus m1g sine theta. The trick here with fgx, it's the opposite side. Sine is opposite over hypotenuse. The hypotenuse is mg. So we take mg times sine of theta, and that's what we get here. And then when we substitute in this into here, we got to distribute the negatives. And then we can solve for acceleration. Let's say that the mass is 10 kilograms, mass 1 is 10, and mass 2 is only 5. Go ahead and find the acceleration of the system and the force of tension. So go ahead and pause the clip and do that, and when you're ready to check, you can hit play to continue. All right, so we should get an acceleration of 1.353 meters per second squared, and then for our force of tension, 55.765.